Hello, this is lecture 3, research methods. I believe I'll split this into 2 parts, make it easier on YouTube and you all, and myself perhaps. So research methods, that's basically, we're going to talk about the ways that sociologists take theoretical statements, turn them into hypotheses, and find ways to test their validity to see if they make sense given what can be learned about the real world. Talking about a lot of statistical based work, but also a lot of field work and observational work. Some off there, well, anyway, just to get here, my usual decoration. Someone's completing a form, putting some information about themselves into a box of some sort. This could be a tax return, but it's supposed to indicate a survey. Someone is taking a survey. Perhaps this is preparatory to an interview by a sociologist or their assistant. Here we have a photo from a famous social psychological experiment by Stanley Milgram on authority. This individual is being wired to an electroshock device. He's going to, or at least it appears that he is being connected to that. Or perhaps he's someone else who's being given a shock just to show what the shocks are like. I'll talk about this experiment, very controversial. The type of experiment that Stanley Milgram did here on authority cannot be done in US universities anymore. So, and here we have an example of participant observation. This is Mitchell Denier, who's one of the authors of the textbook I wanted to use for this class, but was not able to due to administrative issues. He is selling used magazines on the streets of New York on 7th Avenue, Avenue of the Americas. Before September 11th, 2001, when the Twin Towers were hit by a couple of planes, homeless, unhoused, let's say, booksellers would set up tables along Avenue of the Americas near Greenwich Village, in Greenwich Village, I think actually in this case, and sell these used magazines and books to passersby. They might get the books from recycle bins. Sometimes people would donate them directly. So there is a book and a film called Sidewalk, which details his analysis of the world of the bookseller. It's what's called an ethnography, a study which documents the entire way of life of a group of people. The film is more or less a follow-up to the book. I mentioned earlier that in university intro to sociology classes, you often have to buy an additional book in addition to the textbook, and that the McDonaldization of Society was one of the 2 most commonly selected books in classrooms. Sidewalk is probably the 2nd most commonly selected. And if you need an extra credit assignment, let me know. There's one ready in the chute concerning Sidewalk. You can watch the 1-hour film on YouTube. It's in 3 parts. And I already have the structure of the assignment set up. So if you want a 100-point extra credit assignment to substitute for something else or just to help out, let me know. Starting with a little bit of philosophy here. I mentioned this earlier. Empiricism compared to positivism. This is where that is important, really, in a sense, at least in understanding what lies behind these efforts to understand the social world. And once sociological research is published, given to us, how far can we really go with it? So ultimately, from a philosophical standpoint, Many don't take this point of view, but anyway, this is about general approaches to research. Now, empiricism, that's an idea developed by some British philosophers in the 18th century. George Berkeley, John Locke, David Hume. The idea that all of our knowledge comes from our senses, observation. This may seem really uncontroversial, but there was a belief that certain kinds of knowledge about the world could be deduced directly from certain experiences, from other sorts of claims that you could learn something about the world from the axioms of Euclid, geometry, for instance. There are, for instance, the notion that two parallel lines never intersect. The idea that that tells you something about the world. Well, people thought it did, but it turns out that space is curved and two parallel lines can intersect. So anyway, nevertheless, empiricism, using your senses to make observation. Empirical evidence just means information you gain that way from some sort of observation. Could be your senses, or it could be your senses aided by it too. Positivism, related to Comte's positive stage, of which sociology was the best example, the epitome of positive knowledge. Positivism is the idea that the only way to obtain true, valid knowledge is using scientific methods. That's a bit of an oversimplification, but we won't worry about that now. You've seen this before, the scientific method, these 6 steps. I won't trouble you with that. You won't need to know that, because it turns out most scientists don't follow this path. To go back to philosophy, there's 2 types of logic. Logic is reasoning from premises to a conclusion in many cases, or it's reasoning from your observations to a conclusion. Reason is just using our minds systematically. Okay. There's deductive logic, making deductions. That's where you have assumptions. And if the assumptions are true, then something follows from that. So you can conclude something from that that must be true. The classical example, Socrates, ancient Greek philosopher, is a human. All humans are mortal, meaning all humans die. So if Socrates is a human and all humans die, you know Socrates will die, right? But you can't get around it. That's the kind of logic you see in mathematics, for instance, geometry, proofs, for instance, if you had to go through that. Inductive logic is where you make observations and you draw a conclusion based upon the preponderance of the evidence you've seen. Philosophers have a troubled relationship with induction. This is often where scientists get their ideas for what might be a valid hypothesis, or allow them to choose between competing hypotheses, doing some observation and conclusion. But typically, in terms of the classic scientific method, you already have a body of theory. There are certain things you can deduce from that theory, a smaller scale, middle range idea, a hypothesis that if this theory is true, then this has to be true. So I'm going to observe the world and see if I see this thing that's predicted by the theory. If you don't, then it puts the theory into question, or it can. It doesn't always. We'll talk about that in a moment. But inductive logic, as I said, philosophers have some issues with it. Its validity is questionable. For instance, let's say you're a chicken and you know about logic. Am I sharing my screen? No, I am not. So let me share the screen. Sorry about that. You didn't miss much. We're here with the chicken. You don't know much, but you know logic as a chicken, and you live in a cage, something, you don't know what it's called, but let's say it is a cage. And occasionally you see some activity in some thing, large thing, brings you some shiny cylindrical thing, and it turns it over, and some sort of pellets fall out, and it smells good. So you eat it, and it tastes good, and you feel good. You're satisfied. And you notice this happens the next day, and the next day, and the next day. So if you're a chicken, you have to develop a theory of the world based on induction. The world is this place where this thing brings me food every day. And I eat the food and I feel happy. I'm satisfied. Well, one day the farmer brings an axe instead of the food, and you become the farmer's dinner. Your theory has just been falsified. So, David Hume, who criticized the notion that inductive logic could give you true knowledge, used to claim that the fact that the sun has come up every day is no evidence for the claim that it's going to come up tomorrow. That's kind of extreme. He did admit that in practice you have to behave as if that is the case. But when you come right down to it, you can't establish philosophically and logically beyond the shadow of a doubt that it's going to come up the next day simply because it's happened every single day. And this is an example of that fact. Thomas Kuhn wrote a book called The Structure of Scientific Revolutions. It was published in 1962. It's been called the most important and influential book of the 20th century. That's a big claim. I don't know. I'm sure that flatters him. I'm not sure he agrees, but it caused quite a stir because he made the claim based on his analysis of the history of science that science didn't operate the way the people who wrote about the scientific method, as we saw in that slide, said it did. Scientists often used hunches, guesses. They might test an idea that other people had tested and found to be not fruitful at all. So Kuhn, a little background, he was a physicist, and either he was well connected or he was quite a powerful student, because when he started graduate school at Harvard University, the president of Harvard approached him and asked him to develop a history of science class for Harvard undergraduates. So he began to work on this, and he's studying the history of science, and that's when he realized that things didn't work quite the way that some philosophers of science said they had. An influential one was Karl Popper, probably the most influential philosopher of science at the time. He said in order to be a scientific theory, it had to be falsifiable. You had to be able to do a test that would show that this was not true, that the theory was false. If it wasn't falsifiable, it couldn't be scientific. There are problems with that beyond the fact that that isn't usually what scientists were doing. Scientists weren't usually trying to falsify their ideas. They're trying to validate them. So, but Popper said that is the method scientists should follow, falsification. For instance, an example, let's say if I make the claim that in the house across the street, there is an orb of gold the size of an SUV. Well, that's easily falsifiable because someone could go over there and make that observation. But does that make it a scientific claim? No, I don't think so. Has nothing to do with science. Similarly, Popper was interested in the problem of demarcation. How do you tell science from non-science? And this was an issue that troubled a lot of philosophers. Because in principle, let's say again, another example. I say that tomorrow a comet will hit the city of Chicago and wipe it out. Okay. Well, and my basis for that is a dream I had. All right. So that claim is falsifiable. We can see how what happens tomorrow. And if Chicago is not hit by a comet, then my claim was falsified, but that does not make it a scientific claim. It came from a dream. had no evidence or basis or theory to support it. Nevertheless, let's move on. So Kuhn looked very closely at what were called scientific revolutions, times when the entire structure of the theoretical edifices of science changed, when one theory that had been believed for hundreds of years gave way to another one in the space of a short period of time. A good example would be when Copernicus published De Revolutionibus Orbis Celestium, Revolution of the Celestial Spheres, or orbs, which said the sun, not the earth, is the center of the solar system. It had been believed since the ancient era. Some Greek philosophers said otherwise, but the general thinking was the earth is the center of the universe. It does not move. These things that are moving, the night sky, the planets, the stars, they are set in certain shells, spheres that surround the earth. And those rotate. So there were issues with trying to explain some of the motions. So a philosopher in Alexandria, Egypt, Ptolemy, I forget his last name now, wrote a book which became, the shorthand for it was the Almagest. That name came through Muslim scholars that had preserved it for hundreds of years when the religion that dominated Europe, when certain members in the early days of Christianity, a lot of the work of the Greeks and Romans were destroyed. It was believed to have been inspired by pagan practices, by demons and so forth, and it was somehow unholy. So it was mostly destroyed, or the paper was the parchment on which it was written was reused for something else in a monastery. But these books had made it to the Arab world, and they eventually turned up in Spain, and from there they made their way back into Europe and into our tradition. But Ptolemy's Almagest had this very complex system. It mostly predicted your observations, but Copernicus wasn't satisfactory. So anyway, he advanced this theory. He didn't actually, it was, I think, published very close to his death. He was very reluctant to publish it because he knew he was making the claim the earth moved, and everybody knew it didn't move, because if it moved, then if you threw a ball into the air, the earth should move under it and the ball should fall somewhere else. So anyway, he viewed scientific revolutions as proceeding more or less as follows. He wrote about something he called a paradigm, introduced the term into popular vernacular. It may have faded now. It used to be, you couldn't escape the use of the word paradigm in business, in education, in medicine, you may still hear it. Paradigm is a Greek word for model. So a paradigm is the general model that scientists in a given period accept as being true, as being legitimate. The paradigm not only tells you how the world is, it tells you how to go about studying the world. And most of the time, when there's a stable paradigm, the scientists are engaged in what Kuhn called normal science. They're just fleshing out the details. They're making measurements based upon the assumptions that can be, the claims that can be derived from the assumptions embedded in this paradigm, this theory, this set of theoretical statements. But what he found is quite often, eventually, people will begin to find problems with it, or have so far in previous dominant paradigms. You see something that isn't right. And the first thing that tends to happen is you adjust the theory a little bit to make up for this particular problem, and something else may turn up, and then you have to add something else, and eventually you've made so many little ad hoc adjustments and modifications that the thing seems kind of shaky. So someone else comes along and says, wait a minute, we're going about this the wrong way. Let's reformulate all this. And it's so much different than the previous paradigm that the people who are invested in the old paradigm just say, no, I will not hear of it, can't be. And then you have another group that says, yes, I think this new paradigm is better. It explains these things you cannot in your old paradigm, and it explains everything that your old system could. So what tends to happen is, at least according to some philosophers and physicists, is eventually the people who hold on to the old paradigm die off. But while they're all alive, the proponents of both, you call this crisis science. They're busy, one side's trying to fix the old paradigm or theory set, the other's establishing the new. And the scientific revolution has occurred when the people who believe the old paradigm are gone. The opponents of the new are gone. That's, again, an oversimplification. I should mention, since we just went through theory, I don't think I mentioned there's no single sociological paradigm that's accepted by most sociologists. So conflict theorists and structural functionalists see the world differently. Kuhn would have said that people who hold different paradigms are literally in different worlds, and they can't say anything meaningful to each other. That is a bit far. He had to walk that back. Anyway, still influential. Moving on back into sociology from philosophy, there's two broad types of sociological research, qualitative and quantitative. Qualitative, related to the word quality, a characteristic. Quantitative refers to quantity, number, something you can measure. Okay. Qualitative is, for instance, something like, it could also be called a categorical variable. It's, for instance, gender, which historically there were two. I mean, you can expand that, of course, we now know. But in any case, they're going to be individual categories. They're not something numeric, like height or weight or the percentage of lead in a bar of fake gold. So qualitative research, description, classification, analysis of observations that you're making, or text, for instance, textual analysis. These are some of the types of qualitative methods. Observational can be participant or non-participant. Ethnography, I mentioned that, veneer, characterizing the way of life of a group. Open-ended interviews where people just talk, you ask a question and you listen to everything they have to say. There are also closed-ended interviews, but those tend to be more quantitative because you code those answers. Content analysis involves analyzing how words are used. What word is most commonly used? And are there words that are more commonly used in stories, for instance, about someone from a lower socioeconomic class, and words that are more commonly found in those stories about the upper class, the elites? Are they treated differently? Case studies, where you do a detailed analysis of how a particular event occurred. And there's historical and comparative research. That should be an H instead of a G, by the way, where you're using historical materials, or you're doing cross-cultural, cross-temporal comparisons. Quantitative research here involves analyzing numerical data from surveys and experiments, usually using statistical methods. Some examples: surveys, pre-coded, closed-ended interviews. That means the answers are fixed and they can be coded for statistical analysis. Experiments. An experiment is where you're controlling the conditions in which some event is going to take place, and you can vary the conditions to see to analyze the difference in outcome if you choose. A lot of this research ultimately involves statistics, fitting a statistical model to some observational data or historical data that already exists. Someone else has made the observation, you have another idea about what to do with it, and you create a statistical model to investigate it. A few qualitative methods also can have quantitative components, like content analysis. I mentioned the analysis of text. There's software to do just, it will give you a list of every word and how many times it's used in a particular test. Case studies often can involve a lot of statistical analysis, and the historical comparative methods can involve both. All right, a little introduction to statistics, very briefly. Statistics is the science of learning from data. Straightforward. Data is just information, some properties that describe things. A variable is a feature of interest that can be described numerically or classified by categories. Hence, and these categories tend to be different. The numbers are different. They vary, so variable, in different groups. Here are some examples of variables. They can be independent or dependent in the model that you create. Typically, these models will relate one set of variables, which might be considered predictors, to an outcome variable, which might be considered the effect, or the, there's another term for it that I don't recall right now. But in any case, the dependent variables, what are they dependent upon? All the variables that predict what they are or that are associated with them. So independent variables are these things that you are using to predict the value or of your dependent variable. It depends on the value of the independence. The value of one independent variable doubles and the value of the dependent variable doubles. Whoa, you have a relationship there. Maybe it's significant. Anyway, we'll talk about that in a moment. Descriptive statistics is just simple numeric summaries of your data, average, median. Inferential statistics is what eventually that leads you to. You're creating models to compare the groups to see if the differences could have just occurred by random chance, or are they too different for random chance to be an explanatory factor? And here's some examples. We don't need to worry about that. Regression analysis, though, if you've taken algebra and you remember the equation y equals mx plus b, y is a variable, that's a dependent variable, m is the slope, x is the x variable, the independent variable. That's a regression equation. Univariate regression is regression of single variable. A mean is another word for the average. A median is the midpoint of a range of data. Means and medians are different. Now they're the same if you're talking about the normal distribution, the bell-shaped curve, but in many variables of interest to sociologists, the distribution does not follow the normal bell-shaped distribution. It's important to know the difference because often you'll hear a news story where they talk about the average of some sort, the average home price in an area, and then you may see another one that says the median home price. Average is just, if you have a lot of really high numbers in your data set, the average is going to distort what you actually see. The median will take care of that. So for instance, you've got a town, 499 workers make $10,000 per year at a job, but one person makes 10 million. If you take the average of the 500 salaries in that town, the average is $29,980. But that's 3 times what almost everybody makes. So does that tell you much about the income in that town? You certainly Certainly, if you plotted it, you'd see a high degree of inequality. So look at the median, though. That's, you take everybody, all 500 people, you arrange them in order from who's paid the least to who's paid the most. You look at the halfway point. That's your median. Half or above, half below. So in that case, that one in the middle is going to be 10,000. That's a better estimate of what incomes in that town are really like. You would call on that distribution, except for the fact that its inequality is very high in this country, and this is an extreme example perhaps. In general, you'd say there's an outlier, this 10 million. It doesn't fit the rest. Here's our normal curve distribution, the bell-shaped curve. In that ideal curve, the mean and the median are the same number. The mode, which is the most common value, that's also the same. This indicates this range of values is the variance. How much variance is there? If this is flatter and spreads further, there's more variance. You can calculate variance. Standard deviation is just the square root of the variance. You've probably heard that term before. Here's a distribution. This is the distribution of annual household income at 2010 estimate, so it's a little more intense, but you can see it's not that bell-shaped curve. The median in 2010 is around 50,000 in inflation-adjusted dollars. It's around 57 nationally in inflation-adjusted dollars right now. It hasn't really changed much in the past 20, well, this is shortly after the financial crisis of 2008, 2009. So it is up considerably from that. We're probably going to see it going back down again because by all indications are the economic collapse that's being, connected with the coronavirus lockdown is going to be worse than the financial crisis of 2010 and is going to rival that of the Great Depression of the 1930s. We don't know yet how bad it's going to be. So at this point, well, let me finish this. Cause and effect, causality, one thing causes another. Often that's how scientific statements are framed. In physics and chemistry, for instance, you can find cases where if you have a specific condition or property, or a couple of those, you always get a specific effect. If you combine a specific amount of hydrogen with a specific amount of oxygen, you get a predictable amount of water. There are equations that help you do that. Relationships between the things sociologists study are not like those. There may be some probable outcome from a set of initial conditions. For instance, if you are a child from a household that is in the top 1% of income distributions, you're probably going to go to a better college than someone from, let's say, the middle class, the lower middle class, with an average academic record. You probably are going to go to a much better college, but not necessarily. So you involve these kinds of, you evaluate these sorts of probabilistic relationships using statistics. One of the statistics, an easy one that people see, we talk about, I'm going to talk about it very briefly, is correlation. You often hear, particularly regarding medical issues, health, diets, the intake of foods that are allegedly bad for us. They may say eating a particular vegetable is good for you, your health improves. They may say it's correlated with a reduced risk of one disease or another, eating lots of green vegetables. That doesn't necessarily mean that there's a causal relationship. Something else could be causing this relationship. It's a spurious relationship. You're just not looking at the right variable. Okay, well, correlation, so you need to be skeptical of some of these things. Correlation does not imply causation. Correlation is the amount of change in one variable that occurs with change in another. It can be positive or negative. For instance, if it's positive, when one variable value of one goes up, the value of the other one goes up. If it's negative, one goes up, the other goes down. And if they're correlated with each other and that correlation is statistically significant, that doesn't mean one causes the other. It means they're correlated. And that's really it. Here's an example of these two correlations from some actual data. Spurious is one that's coincidental or doesn't make sense. Your theory can't tell you why they should be connected. Even if your theory does tell you and it makes sense, you can't be sure there's causation. There are some sophisticated statistical methods like structural equation modeling and path analysis that can allegedly reveal causal factors, but I'm not skilled in those methods, so I don't know of their flaws and benefits. So a lot of media research, a lot of media stories, sensational findings are kind of shaky on whether they're distinguishing correlation and causation. Confounding variables is something that is correlated with both variables, but it's not measured in the model. Here's the classic example. More ice cream is sold in the summer than in the winter. There are more murders in the summer. Does that mean ice cream is causing more murder? Is causing murder? No, but it's correlated. Now, they're both correlated with summer days, which are longer and they're hotter, maybe more stress, and then are longer days, more time to get into some situations. So it's better to say that the two things are responding to some other variable, the change of seasons. These are actual correlations from the data that obviously aren't causations. As the sales of comic books went up, more computer science doctorates were awarded. Do you think that's correlated? Probably not. Injuries related to falling televisions is significantly correlated with undergraduate enrollment at U.S. universities. What's going on there? Well, this is an easy one here. It's similar to this one. Televisions have gotten bigger, and there are more people going to college, so they correlated. I have, however, found one student who said he decided to go to college after a television fell on him. He was working at Best Buy on the loading dock. He was, I guess, on the ground or somewhere, and someone was unloading a truck and dropped a television on him. He was injured, had to go to the ER, and decided there has to be a better way to make a living. So that was a case where it was causal, I would say, but overall. Shark attacks and tornadoes. I think this was the Sharknado phenomenon, but it's not constant, but nevertheless, you can see the pattern. All right, this is where I'm going to stop. And this is the end of part one. I'll take it up here when I am restored. See you later.